All right, ladies and gentlemen, we're looking at deductive reasoning A. We're looking at using symbolic notation to represent logical statements and form conclusions by applying the laws of logic to true statements. The law of detachment. P to Q is a true conditional statement. If P is true, then Q is true. Law of syllogism. If P to Q and Q to R are true conditional statements, then P to R is true. Deductive reasoning using facts, definitions, accepted properties, and a logical order to rate a logical argument. This differs from inductive reasoning in which previous examples and patterns are used to form a conjecture. Okay? So this one, for deductive reasoning, is facts, definitions, and accepted properties. So let's look at example 1A. All right. We've got the sky is cloudy. We've got the sky is cloudy, and Q is it's raining. So let's look. We took P, not P. That little curve thing in front of your P is not P. And it should say the sky is not cloudy. So for A, I know there's a little square there. There's supposed to be a little curve. Derek? So for under A, you should have not P, which means the sky is not cloudy. Right. So if we have not Q and Q is it is raining, not Q would be it is not raining. There we go.
That squiggly line front means like
not. Means negative. Make it negative. So for C, we're going to make a conditional statement. That's what P to Q means. So we've got, so we know P, since it goes P to Q, we know P goes first. So if the sky is not cloudy, we got P, then it is raining. If the sky is cloudy, then it is raining. Makes sense, right?
Not at all.
You don't understand that P is the sky is cloudy and Q is it's raining. We get that part?
Yeah.
Okay. So conditional statement, we stick the if in front of it. If the sky is cloudy, then we make the conclusion it is raining. Okay. So if we switch Q and P, we put Q first. So we say if it is raining, then the sky is cloudy. Let's take this back one step. If the sky is cloudy, is it raining? Is that a true statement? No, this is false. What about if it's raining? Is the sky cloudy? Sometimes you can see the sun shining through it, but there are clouds up there. Okay? Now we're going to say not Q to not P. So do we get that? Here's my conditional statement. When I switch Q and P, that becomes a what? What happens when we switch them? What do we call that? No. Converse. There we go. Okay. So now we're going to say not Q to not P. If it is not raining, then the sky is not cloudy. Is that true or false?
False.
Just like I have it up there. What is it called when they're switched and we make them negative? Inverse is when you make them negative. Switched and negative. Contrapositive. Okay. What about not P to not Q? Does anybody want to try? What would that be? Go, Dana. Not P to not Q, the last one.
If it's not raining, then it's not cloudy.
If it's not raining, then it is not cloudy.
Wait, P to wait.
Not P to not Q. If the sky is not cloudy, then it is not raining. So that's F.
Right.
And what is that called? And what is that called? Not P to not Q is inverse. Good. So I hear a lot of mumbling, which usually means somebody's confused. What are we confused about?
I said E, so I thought you meant E.
Oh, okay. If the sky is not cloudy, then it isn't raining. All right, let's look at example 2, why some people are finishing writing. Let P be today is Monday, and let Q be there is school. How would we change that into a contrapositive? I hear somebody saying it. Go ahead.
I'm a little tired of this row.
You weren't here yesterday, so we all know that this is your first time trying it.
Okay. Wait.
Go for it.
There's school.
If there is no school, then
It's not Monday?
if there is no school, then it's not Monday. Contrapositive is when you flip it. So look, I did it right here. See how P is the hypothesis, Q is the conclusion. I went to not Q, not P. So I flipped it. So I took there is school and put if there is not school. And then I put then today is not Monday.
So contrapositive is flipping and adding.
And making it negative.
It would be two.
Is it true or false? If there is no school, then it is not Monday. False. Because is there ever a Monday where we don't have school?
Yeah. Labor Day.
Martin Luther King Day, all kinds of stuff. Right. Okay, we're going to write the inverse of this statement. Somebody want to try it? What does inverse mean, first of all? It means you put what in there? Negative. So what do you think it would say? If it's
Not Monday.
then correct. If it's not Monday, then there's no school. Inverse, just put those nots in there. Okay, while you guys are writing this down, I'm going to flip it over and read the back, so if you want to look along with me, if you're done with the front. Jamal knows that if he misses the practice the day before the game, then he will not be the starting player in the game. Jamal misses his practice on Tuesday, so he concludes that he will not be able to start the game on Wednesday. Is this valid or invalid? Do you think he's going to start the game on Wednesday? No. So that would be a valid statement. I'm going to move this up a little bit. Please say something if you need it. So I've got that it is valid. Okay? And what this is saying is we've got a conditional statement. P to Q. And they're both true. He's not on a game. He's not practice Tuesday. So he can't go start the game Wednesday. Let's read B. If two angles form a linear pair, then they are supplementary. A and B are supplementary, so they form a linear pair. Valid or invalid? So, if I've got two angles, these two angles right here, you're saying, form a linear pair. They add up to 180, but do they form a linear pair?
No.
What does a linear pair have to have? They have to be adjacent. Very nice, Sam. So that's why it is an invalid or a false statement. If two angles are vertical angles, then they are congruent. Angle ABC and angle DBE are vertical, so ABC and DBE are congruent. Valid or invalid? Valid. Valid or true statement. Michael knows that if he does not do his chores in the morning, he will not be allowed to play video games later that day. Michael does not play video games on Friday, so he must have not done his chores Friday morning. Valid or invalid?
Valid.
Invalid. He might be going out with a friend. He might be going to a movie. Okay? So those are all what we call the law of detachment. If the hypothesis is true, then the conclusion needs to be true. Okay, now we're going to look at the law of syllogism. Syllogism, it's a very funny word. Syllogism. The law of syllogism says if the hypothesis goes to the conclusion, and then the conclusion becomes the hypothesis, and it goes to another conclusion, we can say the original hypothesis goes with the new conclusion. I know, you're all like, what are you talking about? Okay, I will show you right here. We're going to use this as an example. If a bird is the fastest bird on land, then it is the largest of all birds. So we're going to look right here. It is the largest of all birds. Does anybody see a hypothesis that starts with the largest of all birds?
You said what?
1, 3, 4, 5. Does anybody see where the hypothesis, the first statement, starts with the largest of all birds? The next one, right? See how those two match? We can then, because of that, create this statement. If a bird is the fastest on land, then it's what? Then it is an ostrich. You guys see how that worked? Okay, since the conclusion of this statement matches the hypothesis of that statement, these two must form a statement. Yep. Let's look at another one. Is there any others that start with if a bird is the largest of all birds? Which one? 4. So I've got 4 and I've got 1. So I can say if a bird is the fastest on land, then it is flightless. Alright. Let's look at, because we've used 1, 2, and 4, let's look at 3. If a bird is a bee hummingbird, then it is the smallest of all birds. Is there one up there that says it's the smallest of all birds?
Yes.
Which one? 5. So I can say if a bird is a bee hummingbird, then what? It has a nest the size of a walnut. All right, I am just going to do A from 2.3, B. And then I will let you do the rest for extra credit. How about that? So we're looking at 2.3B, example 1, A. It is detachment. Why? If an angle measures more than 90, then it is not acute. So I tell you my angle is 120, and it's not acute. Is that true or false? It's true. Okay? So that's what you would do with B, C, D, and E. Tell me if it's true or false. If it's not true, tell me why. Give me like a counterexample. For B, you're going to write the premise in order that makes it valid. So